determine algebraically whether the functions are inverses. Okay. I know I've written this down a lot, but every time we want to see if something is an inverse algebraically, we take one equation, switch the x's and the y's, and then solve for y. So in this case, in part I, if I want to see if these are inverses, I could start with the original equation, which is y equals 3x minus 6. I could switch x and y. That would give me x equals 3y minus 6. And now solve for y. If I solve for y, well, I'd have to add 6 to both sides and then divide by 3. Does it match with the equation that they gave us as the second equation? No. They have x minus 6 divided by 3. We got x plus 6 divided by 3. They're close, but not inverses. If we were to graph both of these, okay, y equals, because the part B says to verify it graphically, the one equation was y equals 3x minus 6. I'll do that one in blue. And so your skills from graphing from grade 10 will come into play. You need to remember, how do we graph lines? Do you remember that when a line is in this form, mx plus b, the b value is your y-intercept. So on my graph, 1, 2, 3, 4, 5, 6, I'm going to have the point 0, negative 6. It's pretty easy to see that it would be your y-intercept, because algebraically, how do you find a y-intercept? You plug in 0 for x. When I plug in 0 for x, it's really obvious that y will equal negative 6. The second thing you have to remember from grade 10 pre-calculus is that the m is your slope. And the slope of a line is described as its rise over run. So the slope being 3 is technically 3 over 1, which means I can go up 3 over 1, up 3 over 1. And that's enough to label those couple more points and draw my straight line. The second graph that they gave you, the equation was y equals x minus 6 over 3. This is also a line, but you would have to divide the x by 3, and I would write it as 1/3 x, and the 6, negative 6 by 3 to be minus 2, so that I could change it into y equals mx plus b form. I now know that my y-intercept on my green graph is 0, negative 2. My slope is 1/3, which means I go up 1 over 3, up 1 over 3. So I have the point 6, 0, 3, negative 1, can we see graphically that these are not inverses? How do we see if something graphically is not an inverse? Well, graphically, it would have to be a reflection over y equals x. Graphically, if I have 0, -6 on my blue graph, I should have had -6, 0 on my green graph. The coordinates should get switched. Does that happen? No. Graphically, if the green graph crosses the diagonal line here, the blue graph should cross the diagonal line there. There's a lot of things graphically that tell us these are not inverses of each other. Now, if we look at our second example, the second example, they start with y equals negative x squared plus 3. And then there's a comma. And no, x is bigger than or equal to 0. So this question has a restricted domain. Normally this would be a full parabola, but because the domain is restricted, they probably only gave us half of the parabola. So what we need to find out is, does this match up? Algebraically, switch x and y. And when we switch x and y, we would get x equals negative y squared plus 3. And some people would say, well, if your domain is restricted and you switch x and y, you would also get that the y values have to be bigger than or equal to 0 if originally the x values had to be bigger than or equal to 0. So when we switch x and y, we switch x and y everywhere. So now we have a restricted range. If I'm solving this, I would like to solve for y. Right now my y is squared, so I would move the 3 over, then multiply by a -1. And now I can square root. And since the y value has to be bigger than or equal to 0, does it make sense that you can't have the negative out front? Anytime I have a negative out front, I would get a negative number. So since y is greater than or equal to 0, then the only answer is the positive one. Y equals the square root of negative x plus 3. We check how the equation was written. Can you see that this is the same as this? Negative x plus 3 is the same as 3 minus x. And so the answer to this one algebraically is yes, they are inverses. This one in particular, I think, is a lot easier to see from the graphical perspective. So again, I'll write graphically here. I will graph in blue the original, which was negative x squared plus 3, where x is bigger than or equal to 0. Normally this would be a parabola, vertical reflection, opening down, vertical translation, shifted 3 units up. So as far as being able to graph it, I would have 0, 3 over 1 down 1 over 1 down 3. And I'm going to graph it first with a dotted line. That would be the whole parabola. But since x is greater than or equal to 0, we only have this part of the parabola. So I can even take out my eraser and get rid of this part. I only have that half of the parabola. Does it match up? with 3 minus x. How would I graph that graphically? Well, I have a horizontal reflection and a horizontal translation. That special note that we wrote down that maybe some of you put a reminder to come into your phone every night at 10 p.m. I have to write this in factored form. Factor out the negative leaves me with a square root graph, horizontal reflection, which means that it's now going this way, translated 3 to the right. So I would have this point, graphically. Does it look like it's been reflected through y equals x? Do the points match up? I have 0, 3 on the green one. I have 3, 0. On the blue one, I have 1, 2. On the green one, I have 2, 1. And on the green one, or the blue one here, I had, this one was at 2, -1. And on the green one, sure enough, I have -1, 2. So graphically, we see the reflection over the diagonal line. We also graphically see that the points have been switched, so we can say that yes, they are inverses that way as well. So questions for practice on this one are 7, 8, 11, and 13. And in my notes, I have 11 and 13 with a star. That means that they're problem-solving questions. They will require a little bit more thinking on your part.